call.
I'm just going to do a quick thank you all for coming today. I'm Kevin Kraft, the head of IEEE's Industry Hub here in Silicon Valley. So the hub is really focused on bringing together some of the thought leaders in industry to talk about the applications and use cases of technology, not necessarily the deep, inner workings of technology, but really how it's applied in real world scenarios. So Jehan and the panel, thank you all so much for coming out today. Hopefully afterwards we can have a drink and talk a little more, but again, appreciate everybody coming out today.
Thank you very much, Kevin, and thanks for hosting us. So this all started with Industry Spotlight, which was even before that corporate liaison program within Silicon Valley. And then Corona came, we went entirely online, and then we moved here to entirely face-to-face, which is including this one and the last one, and we have some returning people. I'm really pleased with that from the last event. So the next one we'll try also to broadcast. There's a lot of people, like we have one gentleman join us from India. He didn't know that it's only face-to-face. But that will expand the reach because we have extremely high-quality people here. And we're also sponsored by IEEE USA, IEEE Computer Society, IEEE Future Directions, and the Industry Engagement Committee. But it's primarily organized by Industry Hub, of which Kevin and Jerry are the key people, and then also by IEEE Santa Clara Valley section, of which probably most of are part. So with no further ado, I'd like to introduce to you our esteemed guests. Would you like to say just one or two sentences about you, starting with Natalia?
Thank you. Hi, everyone. I'm Natalia. These days, I'm with Cerebrus. I'm Senior Director of Product, responsible for roadmap for very big chips and software, which is running on very big chips produced by Cerebrus. And my background is mostly on algorithmic side, machine learning, and I'm ex-HPE, HP Labs person.
Okay. Cliff, you want to go next?
Yep, thanks. I'm Cliff Young. I work at Google DeepMind and have been at Google for the last 10 years. I helped build TPU v1 and am still involved with the TPU program. I helped found MLPerf, which is tortures vendors about measuring how fast they train or infer for their various machine learning things. And I continue to work on weird machine architectures inside of Google DeepMind. Looking forward to telling all of you about the next thing when we finally can.
Okay, and then last but definitely not the least, Paolo.
Yes, I'm Paolo. I am a lead of AI research at Hewlett-Packard Enterprise. I have spent my last 30 years of my career working on different aspects of systems. I like to say that I've worked from embedded chips and printers to exascale supercomputers, so pretty broad exposure.
And your claim to fame equivalent to TPU and...
is having written a book with Cliff.
Yeah, nice. But you also did that huge simulator. What's the name of it?
Yeah, we worked on simulation technology for a while.
Okay. So compared to the last time, we won't have many slides. We're just going to engage in the Q&A.
Slides.
I prepared some questions, but you're welcome. They're going to quickly go through them. I know the team. So the first question is the following. How do you perceive the state of accelerators today for running AI applications? We have some people who build accelerators here. We have some people who use them. If anybody should know, it's you. So who wants to start? Okay,
I can start probably. So the question was about the state of accelerators. I think it's not a secret to anyone that the state of the accelerators is the field is very dominated by NVIDIA and by GPUs for different reasons, which we can discuss later. But to me, also, the fact that there are so many other accelerators emerging, TPUs, Cerebrus being just very few of those. We can name very large number of others, and SambaNova, GraphCore, Moffett AI. There are many, Grok, and again, the list can go on for quite long time. To me, that means that people understand that GPUs probably is not the best way to run those things. Also understand that there is a huge market, there is a huge opportunity, and those AI algorithms and applications are really compute demanding. So we all in industry looking for better ways how to run those algorithms. So I think it's a very vibrant space right now, and we're all on the lookout for the best chip possible, how to run those workloads. So a very interesting time for us.
Anything to add?
I think the thing you worry about when you build your accelerator, you're sketching the architecture for the machine that lands in 2 or 3 years, is what if the algorithms change? What if the target changes? Are we sunk in that case? And I think one thing that, for the current moment of accelerators, all the machines that we have today were not designed for large language models.
Exactly.
Meaning no offense to GPUs, TPUs, Cerebras wafer scale engines, or Samba Novas. All the machines that are in prod today hit the drawing board 4 years ago, where large language models, and the Transformer paper was probably a year or 2 old at that point, but the scale that we see now was nowhere in sight at that time frame, and we're scrambling. Like you can watch Google scale its pods up, 256 to 1024 to 4096. Please guess the next number in the sequence, and it's not enough for the current shift to ideally trillion parameter models. Even more ideally in your phone on your phone in your pocket. Please tell me if you have a good idea for how to do that. So I would say, it's really interesting times maybe in the Chinese sense of interesting times. It's great as far as opportunities and terrible as far as the solutions we have. And so it's a disruption moment, which is fun and terrifying. Paolo?
Yeah, I'm gonna use a bit more of an economic argument. I think how I would describe what was the question? The state of accelerators today is unsustainable, right? I mean, the lead time for an H100 is 52 weeks if you're not one of the big players, right? So in other words, to buy an H100, you order it today, you get it in the end of 24. So which means that partly because of what Cliff was saying, that the demand of these GPUs, because they're complete, or anything else, because they're kind of mismatched to the size of the problem we're trying to solve, has grown to a point where the demand is far outweigh the supply. So it's like we're talking about the horse to car transitions, and whenever it happened, is like you can't manufacture enough cars. There are a lot of people that want to drive them, but you cannot manufacture them, and that's the equivalent of training a model, because you don't have the manufacturing capacity in the system to actually do that. Now, markets usually correct that, but that's a situation. But because changing the semiconductor industry is tricky. I mean, you don't double, data center and fab capacity overnight, right? So the most likely the bottleneck on GPUs today is actually not the GPU itself, is the interposer layer that TSMC has to put together with the HBM memory. And to ramp that up is building new fabs, right? So you cannot fix this problem in months. So there is a great opportunity for newcomers because if I can't buy what I want, maybe I will get the second best. But that capacity hasn't materialized even for the newcomers yet. So there's a little bit of a chicken and egg problem, but it actually is a problem, and the industry is suffering at this point.
Okay, and just a quick disclaimer, you may be asking yourself, why isn't anybody from NVIDIA here? We had Bill Daly participate in one of these industry spotlights, so we just can't keep on bringing them. And Steve Keckler also helped with some other predictions. The next question is, what do you see as major trends in accelerators? Where is this industry going? Now, you did answer it a little bit, but I'm just asking to amplify your visionary view.
Who do you want to start?
Whoever is ready.
Yours.
Yes, I can go first again. So trends and accelerators. I think continuing from the thoughts from the previous question, because we know that those workloads are really compute demanding. The trend is how to make them run much more efficiently. And that means sometimes bringing more memory to compute. Also, what's the best way to connect multiple of those together? So they're essentially, I think, bottleneck right now, yes, on compute, but also on things which are around compute, on memory and on interconnects. In addition to that, if you look at newcomers, again, Samba Nova, GraphCore, Cerebras, we all believe in the power of sparsity, and maybe there are some other approaches how to make those models much more parameter efficient when you don't try to train them with brute force dense matrix multiplications, but do a little bit smarter. And I think we're all trying to figure out how to do that and how to build accelerators which can enable you to take advantage of that. Again, also, if you look at a variety of accelerators, many of them switched from standard architecture to data flow architecture. I think that's another trend which we see out there. So sparsity data flow architectures are some of the things which are repeated across several newcomers and I would say trends.
Want to go next? Or?
Yeah, please.
Well, I mean, Cliff mentioned, I mean, the growth, if you look at just the growth of the parameter size, I think the last report I saw, it's growing at 280% a year. If you look at the last few years, I think that's sort of a number. That's actually not the scary number. A scary number is that the computational complexity to train that goes with the square of it if you do it, dumb, right? No, I mean, if you don't think too hard about it. So in practice, if you just map it out a few years, you're gonna hit into the GDP of a small country very quickly, right? So to train the cost of training one of these models. So as what Natalia was saying is that we need to really start thinking about ways to lower the cost of the training to a point that's bearable. Sparsely activated partition, mixture of experts, finding better ways to use precision. I don't know, other things that I'm not even thinking about, but it's not a factor of 2 we got to think about. We got to think about a factor of 3 orders of magnitude, right? Because 2 orders of magnitude, because right now, the brute force approach doesn't seem to be sustainable at the current rate. Now it'll taper off, but not clear exactly when and where. So, would you agree? Or?
Yeah, I agree with all of those demands on efficiency that both of you have mentioned. I will also say that it's terrible that Moore's Law is on its last legs.
Oh yeah,
Dennard scaling died 20 years ago. And even if they were still in effect, just like the glory years of the 90s and the March of the Killer Micros, it wouldn't be enough compared to current demand. And so even if Moore's Law were just great and the next process were twice the compute at exactly the same power and twice the transistor density, we'd still be scratching everything for these efficiency wins. So precision, I think the game is now precision limbo. I can train that network in 2 bits. I can train that network in 1 bit.
Yeah.
I think sparsity is, well, you joke about half a bit, but I think sparsity is what's going to get us below 1 bit per symbol. That is an algorithmic revolution. It's actually a little nasty. Like you talk to HPC people about sparsity, and they want 1 in 10 to the 4th, 1 in 10 to the 5th non-zeros. Neural network training is in the 50% to maybe 90% zeros, or 50 to 10% non-zeros, and that's not quite sparse enough for all the beautiful sparse linear algebra routines that we run in BLAS to port or to lend themselves to new architectural structures. And so, there's a whole bunch of people saying, what might we do? And it'll be interesting, especially if somebody gets a breakthrough. There'll be a momentary bit of leadership followed by a bunch of chasing as people say, what did Cerebras do? And how can we not do exactly the same, but take the principle of what they figured out and move it to other machines and systems?
Can I add one thing?
Oh, absolutely.
And that actually connects back to what we were discussing in the first question, and that is, if I'm designing an accelerator today, or if I have already designed an accelerator 2 years ago, and I am facing with potentially dramatic changes like the ones that, completely changing the training transformer, right, algorithm, stuff like that, then I may be, this over-specialization may be extremely dangerous, right? So that's why kind of a GPU is sort of the, sadly enough, it's kind of the lowest risk approach, because it's somewhat general purpose, even though we know it's not, but
It's not.
more than others, let's put it this way.
Okay, moving to the next question. What are the major limitations that prevent a broader adoption of AI? Now, you've been talking about the future and all of that, and maybe AI is already everywhere, but is it?
Yes and no.
I think we don't know what to use it for yet. I think if you'd asked, sorry, wrong pipe. If you'd asked 2 years ago, we would have said recommendations. I'll take a pause, sorry.
Okay. I think we have tons of dreams and aspirations how to use AI. And every day we are talking to different people who come up with completely new ideas. I don't know how can I feed into my model all of the historical health records, all of their, I don't know, CT scans, blood measurements, ACG, and then come up brilliantly with the best diagnosis and the best treatment plan? I think it's not done today, but it's possible. At least I think it's on the horizon. And there are tons of those applications. To me, the limiting factor is not that we don't know what to do with that, but we have very few people who know how to do that. Paolo just said that you need to wait for H100s for how long?
A year.
Compute is not there, and the high quality data is not there. So there are tons of limitations, and we are trying to fight all of those.
You back?
Okay, maybe I can talk again. Thanks. Sorry about that. 2 years ago, if you asked what was AI actually generating revenue to do, the answer would have been across the board recommending systems.
Yes.
Right. Which ad do we show you? Which search result do we show you? Which thing do you want to buy? Do you want to see? Which movie do you want to watch next?
Yep.
Actually, today, that's still most of where all the money's being made, although it's getting better. But the point I was going to make is business model invention. And to take a historical analogy, at least one of us was a Bell Labs veteran. Bell Labs invented the transistor, 47, something like that, because they needed it, right? They had relays and vacuum tubes, and they could see how badly that would scale, and they looked for the solid-state device that would switch like that, and built the long-distance digital phone system to the tune of hundreds of billions, maybe trillions of dollars worth of revenue. And that was great for what they needed that technology for, but what else did they not use it for? They didn't use it for the computer revolution like Silicon Valley did. And so I wonder about recommender systems being the phone system application of these neural network kinds of things, and whether the companies out there besides the current incumbents are the ones who are going to crack how to use this generic data-driven decision-making technology to invent business models that we have no idea about. So I think the thing to look for is not like, this is a transistor, what do I do with it? I'll use it for my same old business. But how do I transform things the way that mainframes and minis and workstations and PCs and now cell phones have transformed all aspects of our lives? I think this technology, pardon me for having bought into the hype of this, but I think this technology is that transformational because it replaces crappy heuristical decision-making in our systems with data-driven decisions based on actual experience, which is what you want, right? All of computer science is if-then-elses. We can do a better job deciding our if-then-elses based on data is what's at stake here. So I think we've just barely begun transforming things for the limitations of broader adoption of AI. We're not using it nearly as much as we will be 20 years from now. And 20 years from now, we'll look back and we'll say, how do we not notice these applications that we all absolutely depend on today?
Since you touched on data, I was just curious, whose data?
Want to take that? Or?
Yeah, go ahead, Paolo. Thanks for volunteering.
Yeah. Yeah, I mean, I think one of the big barriers is actually the availability of data, the availability of good data, and the ability, not the availability, but the ability to track an AI response, whether it's generative or not, and attribute it to, did it come from the good part of the data or the bad part of the data, right? So today AI systems are extremely primitive in that respect, right? Especially on the generative side, I'm asking a copilot, a code copilot to produce a piece of code. It's getting better, but I don't really know where it came from. Am I breaking an open source license if I'm using it? I would like to know that. But even, if I'm asking something that I expect to be factually correct, then right now I don't have a good way. I mean, there was, our lab director testified in front of the US Senate a couple of weeks ago, and one of the questions was, how do I know that the answer I'm going to get from a generative AI tool is actually something that comes from one of the documents that I trust as opposed to one of the gazillion sources out there? So we need to establish those, whether it's watermarking or whether it's called RAG these days, Retrieval Augmented Generation, which is effectively using AI to retrieve content from a known corpus. But we're still at the infancy there, right? I mean, the data aspects of, yes, it's, throwing the pile is great because now models can learn how we speak. But the answer is still not always what we want typically. So
maybe one reflection on Dejan's question and one flame about what Paolo's just said.
Excellent.
The reaction to Dejan's question about whose data is a really interesting one. I think 5 years ago in the public dialogue about AI models, the claim was you needed big machines and you needed big data to make these things work. And then tiny startups started training large language models. And so the interesting thing is, at least for human language, there's enough data out on the internet
Yeah.
in the public domain that you can actually do general language understanding and
In some languages.
in some languages. Yes. Sorry.
For some.
Pardon my English-centric bias. You're absolutely
There
right.
you go. Bias.
But then there are questions which I think my company is attempting to address about, can you make it more valuable by giving the models access to my personal data, right? Because I can't find stuff as well as I'd like to in Gmail of my own records, even though I have a search engine searching through my Gmail for the thing that I vaguely remember. So could we get better about that? That seems like a source of value. And the balance of, it's still my Gmail data, although Google is posting it for free, and there are very careful legal agreements that people have gotten used to about trusting Google about Gmail storage. How do you build that relationship? If I could go on to the flame about factual grounding, though, like when you solve the factual grounding problem for AIs, can you use it on me, please? Because I don't think my memory is perfect. I don't think I'm factually grounded all the time. I like to believe that I am, but I'm pretty sure I've caught myself being wrong about things I was dead certain about. So this is a super hard problem to get right.
In general, yes, responding to the flame. Sorry, Natalia.
No worries.
You're in the middle here. But you know, there are domains where you do want factual grounding. If someone is asking a support automation a question of how do I fix my sink, you want to give an answer for that sink and not for another sink, right? So you want, or like a refrigerator, which is probably what you get today. So you want step 1, 2, and 3, and you want them to be applied to your context and to that specific thing, not a random one, right? So there are domains like where I agree with you, the factual grounding is fuzzy, but there are other domains where I want an answer from a manual that I want to answer from that manual, right? So especially when it comes to agents and actual actions and not just, you know, creativity of text. Or
Like your car.
like the car, yeah, probably better than a sink. It's a little more complicated. Sorry.
No, I just wanted to support Paul and answer
Excellent.
to Cleve. Like, I cannot multiply in my head 10-digit numbers. Computer can. So if we can teach computer how to do factual grounding, the fact that we cannot do that is not the reason to do not ask computer to be able to do that. And I think that's...
no disagreement. Like having a way of doing factual grounding would be a huge boon to humanity. We just haven't done it in 10,000 years of civilization. So it's a hard problem.
It is, yeah, but I think it's a really important problem, and I don't think that we can use AI in wide variety of critical applications without that factual grounding and without knowing if my model hallucinates or not. Like for generative AI, most of the use cases today, okay, I wanted to write an essay, I want to write a science fiction novel, I want to generate a picture of me looking like a cat. There is no factual grounding, and I'm perfectly fine with the model hallucinating. But if I want to use that for some actual critical task, I want to be sure that the model doesn't hallucinate and doesn't do mad things.
So I think all three of you agreed in different ways that we should use AI as assistant of some sort in different situations, behaving differently, either factually or less so or whatever. And also I think Paolo, when answering my sub-question, you also answered in a way the first question, I mean the big question, what are the major limitations? They are tied to data because trash in, trash out.
Yeah, the data we talked about. I think the economics that Cliff touched upon is the other one. I mean, honestly, there's a great article that came from the Sequoia Capital Group that came out. It's called The 200 Billion Problem, which is basically, hey, we're spending single-digit billions to train these things these days. There better be a value that's generated that's at least 100x that. If it's not, then you know the money's going to dry up quickly enough because someone's going to have to find an actual way to monetize these things and not lose money on every prompt that gets sent to a language model, right? Or
do things cheaper.
Well, or do things cheaper, but a lot cheaper, right? And that goes back to the previous questions, right? So right now, everybody's saying, oh, this is going to generate trillions of new value because it's going to change all the knowledge workers and so on. Yeah, great. I mean, GDPs don't change, by a factor of 10 overnight, typically. So in a more practical sense, while everybody agrees on the long-term perspective is, how am I going to make money out of this thing now? Right now, there's a little bit of a gold rush. Everybody's buying everything they can, but and if they don't find the gold, it's going to be a garage sale, or I don't know what's going to happen, right? But
I love when my panelists engage, but let's move on to finish these to let the audience also ask questions. So the next question isn't mine, but it is for our panelists, and it's the following: hardware for existing algorithms or algorithms for existing hardware? That is the question now. Is hardware software algorithm co-design feasible? Who would like to answer that question?
I'll do the second one first. Absolutely, I've done it. Not at the current job, but at the previous job, I built special purpose computers for molecular dynamics, and we totally did full stack hardware through algorithm restacking of the n-body problem molecular dynamics calculation, and had a target of beating National Lab supercomputers by a factor of 1,000 and hit it. You don't do that without re-envisioning the algorithms and then saying, if I've reimagined this algorithm, what hardware do I build to build it? You have to eliminate 99.9% of all the cycles if you're going to get 1,000x speed up, but you can do it with a dedicated team, and it can be transformative. If anything, because of how quickly we're developing things in the neural network space, we don't often have the time to do that kind of transformative hardware-software algorithm co-design in the way that there ought to be some long-term big bets of that sort, like near training and inference. I don't actually think we really understand what's going on inside of the training processes or inside of inference for a particular neural network model, and we haven't spent the time to do science, statistical analyses, or inventing something like thermodynamics, but for neural networks, to talk about the bulk properties of these neurons and explain why they behave in the way they do. If we did, it might lead to the efficiency breakthrough that we keep on saying we want. And it might take 2 decades or more to get that sort of breakthrough, but that kind of science actually should be happening. It's just that right now we're in the midst of the first industrial revolution. We're building bigger and bigger steam boilers, and giant steam boilers are making for really great shaft power, but that isn't the best way to solve the problem in the long run. It's just what we have today. Dodge the first question, but somebody else can go for the first question.
Now, to me, it's like chicken and an egg and very closed loop situation. And I completely agree with the hardware lottery paper. So essentially, new algorithms which are proposed, if they run well on existing hardware, they will be promoted and they will be used. Exactly. Even if it's a good algorithm, but you cannot run that well on the hardware, it won't get any visibility, it won't move forward. And even for the hardware developers, it's also, you look at the transformers. Transformers came up because GPUs knew very well how to do dense linear algebra. So here we have a model which consists of those Matrix multiplications. Recurrent neural networks in the past, now in convolutions almost in the past, we know how to do Matrix multiplications, and all of the models of today, majority of them use that block. Is it the best block we can build for? Probably not. But because that's what can run efficiently on existing hardware, that's what people keep on using. So to me, it's a really big challenge. And although I think that co-design is possible, it's really hard to do that. And it's really hard to break through existing common practices. And if it's not for a potential like that, multiple orders of magnitude advantage, nobody would do that.
I mean, yeah, not too much to add. I mean, there is a fringe of the academic community, including some luminaries like Yann LeCun and others, who are basically saying we've been doing it all wrong, of using self-correlation and autoencoders. We're going to move to energy-based models and the kind of stuff. The problem is when Natalia is saying that, yeah, even if I write one of those, if I simulate it with a digital computer, I'm nowhere near. I'm actually going to be probably a lot slower, right? So I need to find, where am I going to, where is the magic combination of a breakthrough in the algorithm, but at the same time, something that I can build in my lifetime without inventing a whole new material stack and building a new fab, right? So
Okay, we're done with this.
If you'd like.
you're the boss.
One before the last question, how do you perceive the evolution of AI in terms of ethics and humanity?
Will you want to start?
Whoever wants, I'm not imposing the order. Well, while you were thinking about it, we wrote a paper, and Paulo was part of it, for IEEE column. And one of our colleagues who's not here wrote scenarios. I was depressed when I read it. I put it in table and all, but the last scenario was pretty pessimistic. Last one was hopefully optimistic. It was about assistance. So there's a lot of issues there apparently. So Cliff, what do you think?
I was going to say, right now AI appears to be a tool rather than truly sentient or the kinds of things that we might hope to create. And there's a whole history of humanity about the nature of slavery and enslavement and treating other people as objects rather than subjects that comes into play once we actually have things worthy of autonomy and agency on the table. But we're a long way from that. So just talking about the tools, there's a huge debate, and people like Geoffrey Hinton are calling for regulation and supervision and so forth. And it kind of reminds me of recombinant DNA in the 70s, where there was a public dialogue about this new technology that might have created the supermicro that would destroy the world. And Michael Crichton wrote about the Andromeda strain and so forth. But in the 70s, at least, we had a public technology, governmental, academic consensus about what are the risks of this technology, what constitutes proper lab procedures. Don't put the parasite and its host in the same lab, and don't let them wash down the same drain to the same sewer system, and various other kinds of controls of that sort that allowed the public to reach a degree of understanding and comfort with this new unknown and potentially Frankenstein scary technology. I think this is another time like that. When Mark Zuckerberg goes to Congress and says, I want you to legislate, he's not abdicating authority. He's saying that Facebook alone, or the hyperscalers even banding together, which would be anti-competitive, or the industry by itself is not in a position to make decisions for society that are good for society. This is the job of our government and our public sphere. We should talk about this like participants in a democracy and say, what do we want out of this technology? What is good for the world, the country, individuals? How should we build the legislative environment, which determines how companies like all of ours operate, to create those results in a pro-social way? That's the dialogue we should be having, rather than the scaremongering about it's going to turn us all into gray goo, or we're going to build the next version of Terminators or some other dystopian future, which makes for great Hollywood entertainment, but it's probably not actually what's going to happen to us. I think I see relatively little of that kind of engagement about what should that plan be. How do we put AI in the decision loop for loan approvals? Actually, banks have been dealing with that for 30 or 40 years, and bias is a real issue there. Those kinds of things feel like maybe, I don't know, IEEE and the members of the people in this room, we are not just engineers, right? We're members of our societies. And so that's something where we're uniquely positioned to say, here's how the technology works, and to ask our fellow citizens, what do we as a polity want? So that's, maybe I went more politics than ethics and humanity, but I think that's the proximate problem.
It's good. It's good.
Yeah, I mean, we defined our principles that, I think I forgot, like private, inclusive, responsible, secure, and robust, right? So those are the 5 principles that systems should have, and we want to make sure we look AI through that lens, right? If you understand what you want to achieve, then an AI system shouldn't be different than other systems, right? You want to be inclusive. Well, in the case of AI, that means probably you need to have a way to measure bias and perhaps to reduce bias. You want them robust. Well, you need to figure out a way to test things and see where they break, and so on and so forth. You want them human. You want a human in the loop without having an agent making risky decision. I mean, if it's making a recommendation for my friend in a social network, I probably don't care much. But if it's making a recommendation of, a medical treatment or something like that, I don't want that to be an agent that does it autonomously. I want it to be have a human in the loop that can at least have oversight, right? So all these things are kind of natural when you think about it. And I agree with Cliff, that's how we should look at the AI systems, with a lens of, okay, what are the things that the government or society is regulating already for the rest of how we work and live together? And let's try to make sure that we find what are the angles and particular implementation of those principles in an AI system. And that would, I think, improve the perception of how trustworthy or responsible an AI system can be.
And you, Natalia, disagree with all of this?
Oh. No, I think we definitely should think about those things, but also I believe that the human race doesn't do good job, looking ahead. We are really good in learning on our mistakes. I don't know any nuclear regulations come in place after Hiroshima and Nagasaki. I don't know, traffic lights and things probably came up when there were too many cars and too many people got hurt. So I suspect that we will learn how to use that. We will learn how to use it ethically, but probably before we do that, there will be some.
Sadly so.
Well, there's one tool that is solution to all these problems, and that tool is part of the last question. So if either of you had a magic wand, what would you solve and how?
I'll start and then maybe I'll trigger. Well, I would like the whole AI community to move away from proprietary AI and think about the greater good. Right now there's too much duplication of efforts out there, and no offense to our Google friends, but the fact that we have a Bard and a ChatGPT and 20 other models that are closed, not transparent, behind a paywall or a company wall, it doesn't help. I would like the AI research community to actually get together and develop a lot more in the open, and then someone else will figure out how to make money down the road. I'm not too naive, but at this stage, I would like the research society to be more open rather than closed.
That was a really good one.
Now you gotta do better than that.
Yeah.
Cliff?
For the magic wand part, I project my current problems onto how I think the world should be in answering panel questions, I guess. And I actually think the last 5 years of my career, I've been spending much more of my effort on socio-emotional efforts, on figuring out how people as emotional beings relate as members of teams on my team or across parts of Google, much more so than the technical pieces. And I haven't yet seen, just beyond ethics and humanity, I haven't seen a neural network model be kind yet, be empathetic yet, to sympathize or support or help people to understand what their personal issues are, to be the better angels of our nature. And I feel like I wish that were more a part of the public discourse, rather than, are we going to build the next Terminator? God, I'm so bored of Terminators. Like, the robotics isn't nearly good enough, first of all. But one of the AI, build yourself a personal companion startups had people develop emotional attachments to their personal AIs. And then I think they yanked that back because it started to get a little bit creepy and weird in some ways. But I think the potential there is real, and again, a way that is good for us. That we as humans are flawed and don't always say the most helpful things to our friends. We aren't always the best versions of ourselves. But could we construct the angels, the better angels of our own nature, in these devices? Could we forge them in the image of what we might be and have them teach us how to be better people? That would be a revolution that was worth more than any GDP number can measure. And I don't, I think there's a little bit in Kurzweil's Age of Spiritual Machines. And, at some point, Kurzweil gets a little bit far out for me. But I think, how about just basic kindness? There's little enough of that in the world anyway. So if the machines can teach us to be a little bit nicer to each other, to see others' pain and find ways to make a small accommodation, how much would that be better for us? So there's my magic wand request.
Very nice. Natalia, I want to make the closing statement, or should we go to the audience to hear some nice questions? Okay. At the same time, both of you raised your, so we'll go with Michael and then,
Do you want a mic or?
Want to give me a mic?
um,
I don't care.
just,
So-
I will
so
repeat the
we-
question for recording.
We can hear
In
you.
the discussion, one of the things that was brought up was the data used for AI generation. And the internet is one of the areas that is used for AI content. Particularly look at ChatGPT, that's where it gets a limited income. So in the world of research and publications, the model for kind of a good publication, or at least the acceptable, not just garbage publication, was peer review. So we had an algorithm. It wasn't perfect, you know. You have friends that are your reviewers, but it was an algorithm that said, okay, if you have a double-blind peer review article, generally the person's not just lying. It's not just nonsense. Can we ever envision a way that content in the internet can effectively have some content free and some content essentially peer reviewed as, you know, not necessarily just being a lie? Is that a future? Because if we have that, then the AI engines can use more of the peer-reviewed content, if you will, than just one that is of unknown value.
So 10-second summary for recording, because this is recording mic. Can we have peer-reviewed content on internet so that we can use it for training?
Quick answer. I thought somebody trained a large language model on textbooks and got remarkably good answers on the topics of the textbooks. And so if you think textbooks are representative of a good snapshot of some distillation of knowledge, then yeah, maybe we already have good human mechanisms for it.
Most
And
textbooks are peer-reviewed. I mean,
yeah,
at
absolutely.
least any that I've been involved with, either the reviewer or the writer. So.
I mean, there's two components of, if you're talking about language models. Like there's the component where the language model needs to understand the language itself.
Right.
That doesn't need to have good content as long as it's actually formed in in the language it's trying to learn, right? How people are, how it's used to communicate. Then there is and that helps to generate, the understand the prompt, for example, right? Then there is okay, I want the answer to be factually correct or belonging to that subset of the data. And I think on that one, it's either you train on a subset or you do retrieval augmented generation, meaning that you actually only get the answer from a subset, or something that I don't think it's been invented yet, right?
We do darkly joke about we've got the peer reviews and the original source materials. So could we train a model to produce peer reviews and bootstrap that way? And and while we're at it, the annual performance review process, because that's too much work also. And
I'll buy that product.
do you right? But do you trust it, right? And tough one. Natalia,
Yeah.
come on.
Natalia?
No, I just wanted to say that I had one member on my team, when Copilot went live, he came to me with big eyes and told, we need to download all GitHub now because tomorrow it will be all auto-generated. So,
Well, that's a problem.
I think, yeah, but to your point, I think even auto-generated data can be used for some of their use cases. And we just need to be careful about where the data comes. And maybe we need to come
That's
also
the
with,
challenge.
yeah.
How do we determine to be careful? So let's go to the next speaker.
I'll ask one question first. We know that nowadays the kids, mainly with the internet and chat apps and everything, are not communicating between themselves, they're communicating via these apps. So if you guys have your magic wand and wave it 20, 50, 100 years from now, when a kid is telling the parents, why should I go to school? Why should I learn science? I'll just buy this AI gadget, it knows everything.
So 10-second summary is, will AI and these gadgets replace learning or teaching, traditional teaching?
I mean,
And make them lazy, right?
well,
They
first,
don't see the point.
the lazy part, I think it's already happened. But anyway, I mean, the usual answer I always say is that the teachers that know how to use these tools best will replace the teachers that don't know how to use them, right? It's going to be a new generation of the way in which you teach that will make the best use of these tools. I don't think you can get rid of the expert in the loop and the human in the loop, but maybe I'm being naive. So I'd like to hear other people's opinion.
I think it will just shift what we need to teach and to learn. We will need to learn how to use those tools, but still how to reason and how to understand what to trust, what to do not trust. So we'll still need to teach kids. We might need to teach them something like differently. And
Sorry, last time. I mean, this brings to mind the picture in the 60s of teachers going on strike against the use of calculators because it would make kids dumb, right? I mean, yes, it happened, right? So this is a different scale, I get it, but it's a little different, right?
This knows everything and more than what the teacher knows.
Well, they said, I bet they said the same things in the 60s about the calculator, right?
Yeah, and the slide rule.
Or the slide rule back
I still
before.
have one.
I may be misinterpreting what you said, but
Not using it.
I think that kids have been going to hell in a handbasket with the new devices since Cain and Abel. And it's every generation has this thing. I remember saying, oh no, hearing in Newsweek and media as a kid, Dungeons and Dragons is corrupting kids, and like punk rock or heavy metal were these terrible influences, and the kids who listened to these things were like going to end up being horrible members of society, and they weren't actually communicating, and that wasn't real music. And so I may be pushing back a little bit on your concern. I don't actually get how TikTok is a great way of communicating, but my kids certainly spend a lot of time on it, and they learn some pretty cool things from it. So I don't actually think knowledge has necessarily been destroyed. I wonder if it's been transmuted. And I wonder whether it is differently accessible to the new generation in ways that make some things that are easy for us hard for them, but also the reverse. Some things that we found impossible, they may be like, oh, I'll just snap these two Python widgets together and I'll be able to fly.
So you're saying it's a evolution in a way with some steps in different directions.
The decline of civilization has been forecast for a very, very long time, and yet here we still are when we have iPhones in our pockets.
You mean
Overrated.
Like Moore's law.
Okay, I'm not sure between gentleman in the back and Pankaj, who was first. Gentleman in the back.
All these analogies as to
You may have to speak a little louder. We can't hear you well from here, so.
All these analogies about we've done all this before, nothing bad happens, civilization didn't crack, all that, I think is not the right analogy. Because when you do a calculation, or you look up something, or you do an analysis, you're not really creating new information. Nobody's really going to rely on it necessarily. But in this case, where you're actually going right into the database and creating stuff, it brings out a question of what is the definition of publishing? What is the definition of a revision? What's the definition of a version? And everyone has held those things dear. Both people write books, people write papers. It's important to know this is draft, this is version 0, version 1, this is peer approved, not peer approved. But today, the way it is, there is no such thing as a revision. Everything is constantly changing. So if I say, hey, go look at this thing, when you look at it tomorrow, it may be entirely different from today. So I think that's the problem. It's not necessarily that there's anything wrong with generating stuff with AI. It's that there has to be a way to rev it, to document it, so we know what was changed, the underlying, the pass out, that kind of stuff.
Okay, so 10-second summary. The question brought is that past tools that were mentioned were not generating new information. That's part A. Part B is that there are so many versions of this newly generated information and not being able to track what is the draft versus the real version. So any comments on this?
I don't.
Aren't there comics about like guys staying up late and like the spouse says, come to bed, it's really late, and the response is, no, something is wrong on the internet, and I must fix it. I feel like these issues about factuality have been with us since at least the printing press, and like the answer was more printing presses. So like we do have revision control. It's not as if we've like taken the logs out of stuff. It's not that we've forgotten all of our memories, or we don't have all the records of all the previous versions. They're all right there in Wikipedia. They're all there in the databases that we still build. We're not throwing out those underlying databases. You are right as far as people who work on current perception and sort of say, well, this is what it looks like now. I don't have an answer for those kinds of people because I think they're gullible, but we've always had gullible people as a part of our population. And what we're talking about is how do we curate society where like there's a mixture of people, some of whom actually understand provenance and history. I don't think that's falling out of the world.
I want to clarify. I think we may think that the question is a small question,
No.
but I think if you contrast between search and generative, I think the question is a very meaningful question. It's how did an answer change? So let's say, I'll give you a specific example. Let's say I'm interested in how ROB buffer sizes in processors are changing. So I ask Google Bard today, and I get one set of answers. If I ask them tomorrow, I'll get another set of answers, or maybe not. So, you know, as you go through whatever it is that tickles your fancy, and you act with these agents, the human effort is preserved better if you have a sense of how the answer is changing than if it is not. As opposed to Google, which found things that were published, and then if you use the tools and say, okay, what's published in the last month, you can actually manage, you know, what changed. But here the situation is a little bit different.
So Pankaj, in your lengthy comment, you're really supporting previous question, amplifying that generative AI is much different than traditional search, which is based on facts.
Yeah.
So any comment on this?
Well, I mean, the generation of that question still gonna come from previous content that was absorbed, right? And then I think to me it goes back into the question that were asked before: can we get rid of the experts? Can we get rid of the humans? No, you can't. I mean, again, if you are asking a question on ROB because you're an expert and you read it and you say, well, this is wrong, that's right, because you kind of already know the answer, you just wanted confirmation. But if you're asking a question about a field you know nothing about, medicine or legal or something like that, you're not going to trust the answer that comes out of a generative AI. You're going to pick up the phone and call a doctor, I'm hoping, or a lawyer, and tell you, hey, I got these 3 answers. Which of the 3 do you think is right? Because, you know, there's still, and that's true today, even if you do a search or anything like that, right? So, you know, I'm kind of scratching my head a little bit to understand, you know, who would actually act on the response of a search or an automated thing. Well, my kids probably would, but you know, they think they can do brain surgery by looking at YouTube videos, right? So, but you know, that's not, that falls into the category that Cliff was talking about. You know, perhaps.
It's on YouTube.
Right.
So the way I understood gentleman in the back's question, I think I completely agree with Pankaj. It's an extremely deep question, really. I think the question is more about, can we have explainable AI answer with some snapshot of the data that it based that answer on, so that over the time you can always go back and say, if the answers were different, how were they made, how were they concluded, and which one will I trust?
And provenance, you know, you want to know where you get the information from, right? If it's from, you know, whatever random site, it's one thing. It's from, you know.
But not just provenance, also explaining how it came.
Provenance is part of explaining of explaining where it comes from. Right?
I think it's a hot research topic, and
Yeah,
my guess is we'll get there. Although I caution about, like, consciousness is a funny thing. Like, apparently a bunch of studies about how we decide, and then our brain manufactures a reason for why we decided is kind of what the psychology studies say. So was there actually a good reason for the decision? At least whatever biometric monitoring they're doing in those studies says our brains don't work that way. So would you accept a plausible argued answer from the AI for a decision it was going to make anyway? Because that's just what the humans do. Definitely a very, very deep question.
Explainable surrogates.
I guess people in this room are trained to understand and evaluate the quality of an argument and to check the sources that are inputs to that argument. So if it passes our test, then maybe it's good enough, although terrifying. Yes, in the back.
I think I want to clarify. A lot of people are mistaken when they say that we used to be good, now we're bad. right? If you go back and look, for example, at Shakespeare, everyone says, oh, we know what Romeo said, what Juliet said. Actually, that's not the case. When it was first performed, it was not written down. People just performed it. And then over time, different people from memory wrote down what they thought he or she said. And so the different folios, different versions. Similar with the Bible. It wasn't written when it happened. It was written later based on recollections of what people thought they said, then massage it and maybe censor it. So I think we've always had this generative AI done by humans. Except that the thing was that it was carved in cuneiform, it was on a stone. We can go back and go look for that stone or look for that thing. And today the whole thing is moving all the time. And so maybe the solution is that when you generate something AI, you need to have different pages. One, facts, citations. Two, conclusion, interpretation of facts. Three, my extrapolations of the interpretation of the facts.
Yeah. I'm really sorry we haven't been recording. These are amazing comments. The gist in 10 seconds again is that kind of generative AI existed all along in different forms, except that it took much longer. A lot of things were written and they aren't today. And maybe that's the problem. The generative AI is moving extremely too fast nowadays compared to the past. Any reaction by my esteemed colleagues here, panelists?
I'll wait for somebody else first. I do have reactions, but I feel like
I
I'm taking
don't
too much
have a
air.
reaction on this one, but
Go ahead.
Natalia's been quiet, so.
Yeah, I've been thinking. To me, it all comes down to the very first, one of the first topics that we brought. That whenever you use AI for tasks that require you to be sure in their factual correctness of the information, we still have a way to go. And there is, as Cliff mentioned, active research area to understand how we can make sure that the information factual correct and how we can tie it down to the sources. So that's true. But also, like another part of me think, even if I search at Google, there is so much information which you don't know if you can trust or not. So I don't think that question is unique to generative AI. I think it's it's overall. It's applicable to search engines too. It's applicable to generative AI, and we'll need to learn how to understand what we can trust. And maybe AI can help us with that too. Maybe can train models which can tell us how trustworthy that information is or not.
One +1 to the speaker in the back and one caution. The +1 is Shakespeare has a superhuman vocabulary. If you count the distribution of words, no modern human has half as many words, and it's exactly the process you described. It's his actors' vocabularies unioned over all the different speeches that gives him superhuman range. So he probably sketched the plays, but the poetry in iambic pentameter that we enjoy today is a collaboration of many people's vocabulary and linguistic systems. The cautionary thing I worry about is things like political influence campaigns, right? So Russia interfered in the US 2016 elections in various different ways, and in neighboring states in the years before that, so far as we can tell, using labor, like human labor, not automated chatbots. But if the automated chatbots are even cheaper than whatever you pay Russian troll farms, that's another danger to democracy and our style of life. And I don't think we have great ways to address that. It's the chatbot arms race seems like an awful way to spend resources. Of course, an educated population would be a good thing, but even an educated population can still get denial of service attacks if everything you see in various different feeds is tilted by virtue of these kinds of operations. I think that's a real societal risk. I don't know whether I'll say the West, but the liberal democracies of the world have actually rounded on that particular threat out of all the different threats that we're worried about.
Okay, we have Pankaj, and then I would also like to give opportunity for audience to mingle and talk in person to our panelists. So Pankaj, if anyone else has questions, please indicate after Pankaj.
I'll ask a quick one. You said one thing in answer to the AI ethics questions, but when you are at home with your children and you're thinking about the future of your children and the impact AI could have on which way their future goes, will they be the slaves of AI or masters of AI? A, do you see that dichotomy? And B, what do you tell your children about not becoming victims of future AIs?
7-second summary, what do you tell children how not to become victims of AI?
Use your brain.
Yeah, well, that sums it up fairly well. I mean, look, to me, this is a tool. I mean, I think, tools can be used in the very wrong way, right? A hammer, or pick your favorite, right? So you need to learn how to use it and use your brain to make decision. Hopefully, we have passed on principles that can be applied to this new technology or other new technologies that are going to come, which you're not even thinking about. So to me, it's like we got to go one step back and say, look, these are the principles we try to teach you, apply them, use your brain, and learn how to use the tool. I don't see the doomsday scenario anytime soon. Perhaps I'm being overly optimistic, but in the dichotomy you were talking about, I'm more on the positive side. This is a tool. If you know how to use it, it will help you.
Cliff was smiling when Natalia said brain. I'm sure he heard Google Brain.
No, I was just going to lean possibly a little bit into my personal politics and to your question about how do I teach them to avoid becoming these slaves of the future AIs. The same thing we teach them about behaving as members of modern capitalist society.
Yeah, exactly.
We have intelligences that want to oppress us or expropriate our labor. They're called smart people. And yet we have a society in which we are able to function, and some of us make a decent living and have lives where we're able to be kind. So ideally, it doesn't change that. To your formulation about masters of the AI slaves or slaves to the AI masters, I will push back on that a little bit because I think it reveals it implies a zero-sum world mindset. And you're absolutely right that human history is full of enslavement, terrible colonial kinds of things that we could go into at length. But there are positive sum possibilities, right? It doesn't have to be master and slave or slave and master. It could be collaborator in complementary ways, if only we could phrase it that way. And in fact, what is free trade but comparative advantage in exchange for mutual benefit? All right, different part of capitalist economic orthodoxy. Could the AIs be our partners in building a better world for them and us? That, I think, is a worthy goal or a better equilibrium to look for than zero summary. I think there's a lot of zero-sum worldview. There's a lot of negative-sum thinking going on in the world, which is, by my lights, awful, but I can see why the particular people have chosen to play those chess moves and how it might benefit them. But, we're Silicon Valley nerds and we're optimists. So how about we look for a positive-sum future and think about what makes for mutually advantageous relations?
With this, okay, we got a last comment, if that's okay with everyone, and then the remaining comments and questions you can approach our panelists directly during the break.
Again, I want to say repeat what I said earlier. There's too much nervousness about all this, because if you ever talk to professors and researchers, people have been massaging data for the longest time, right? They know how to make things come out the way they want. That's why papers get published. Nobody ever does something, do a real experiment, collect real data, and just publish it, because it will be rejected. You have to go, massage your PE or K or T, all your different tests, so it needs all the dots. So it's always there.
Thank you. So I would like my esteemed panelists to make the closing statement, like 15 seconds, and I'll start giving you example. My 15-second summary is I was really impressed with some aspects what you said about kindness, really great thing, about this co-design that can change everything, and then, disruptive changes, maybe even changing business model. So these are my insights from your, what did you, in whatever order, 15-second summary?
Summarizing, we should strive to build an AI that is open and kind.
And I think also encourage look into the ways how to how to make it more economically sustainable.
I think people are very much aware of the potential dangers. I think that we should also concentrate on and steer towards the vast potential goods.
Yeah.
And that might be just the best path for us to chart.
as they say, focus on positive, patch up weaknesses. Okay, please let's thank our panelists. So we'll stay around. I know Paulo and Cliff will because I'm driving them.
Captive.
So let's stay a little bit more, talk. Please approach them, and we'll have to pack up the stuff, Pedro and I.